This is Andrew Kamazinski at Hokkaido University of Education, Asahikawa. And today I want to talk to you a bit more about deductive arguments. So last time we looked at deductive arguments, which in Japanese, enekiteki ronsho. And the main feature of a deductive argument is this. If its premises are true, the conclusion must be true too. Another way to say the same thing is that they are truth-preserving. This means that if you start with things that are true, you end up with a conclusion that is true. So it preserves the truth of the conclusion. These arguments work by using a very limited number of operators. By operator here, we mean a word that connects or changes the meaning of what we're saying. And they also follow the three basic laws of logic. So the three basic laws of logic, which we've been going over a lot in class, are the law of non-contradiction, that A and not A cannot both be true when A has the same meaning in both cases. Or to say something similar, the law of the excluded middle. Of A and not A, only one can be true. And finally, the law of identity. A is the same as itself. Now, I want to talk to you a bit about that small set of other things we can say. So the first of these is negation, which is just a big word for not. So this is hite suru. Negation reverses the truthfulness of a statement. To say it another way, negation leads to opposites. So if we have the claim Abe is prime minister, this is presently true in 2015. If we change and say Abe is not prime minister, this claim becomes false. Second claim, Hokkaido is great. This is true. If we change it to Hokkaido is not great, this becomes false. Rice tastes bad. This is false. If we change it to rice does not taste bad, this is true. You are a teacher. Right now, you're not a teacher, so this is false. But if we say you are not a teacher, this is true. So negation works either on one thing or on a group of things that are joined in some other way. So I will explain what I mean by joined in some other way in the next couple of slides. So the next thing we can do is conjunction. So conjunction is just a big word for and. It's setsuzoku in Japanese. Conjunction looks at two things together and says if both of them are true, then the two together are true. If one of them is true and one of them is false, a conjunction is false. So let me give an example. Abe is Prime Minister of Japan, and Dr. Kamazinski is the governor of Hokkaido. So it is true that Abe is Prime Minister of Japan. It is false that I am the governor of Hokkaido. So what that means is that in that case, claim 1 is true about Abe. But claim 2 is false about Dr. K. So the result is that the two together is false. So if we have the word and here, we're joining them. Or if two things are false. So if I said that, let's see, if I said that Koizumi is the Prime Minister of Japan, that is false. And that Dr. K is the governor of Hokkaido, that is false. This is false. So the only way to make a conjunction true is if both parts are true. So Sapporo is in Hokkaido. Asahikawa is in Hokkaido. So conjunction looks at two claims together. So let's look at a couple more. So Abe is prime minister. True. Hokkaido is great. True. Rice tastes bad. False. You are a teacher. False. So I will just give you a second or two to look. But the basic pattern is anytime that we have something true and something true, it's true. So these two together give us this one. But if we have something true with something false, it becomes false. Same thing here. If we have something true and something false, this is false. But if we have something true and something true, it is true. The order does not matter. A and H is the same as H and A. And again, if we have two things that are false, it is false. So disjunction is a big word for or. So or means, in this case, if two claims are there, if either claim is true, then the disjunction of the two claims is true. So again, Abe is Prime Minister of Japan, and ice cream tastes good. True, true, true. Abe is the Prime Minister of Japan. True. Dr. K is the governor of Hokkaido. False. Still true. So Dr. K is the governor of Hokkaido. False. And let's see. And it is snowing outside. True. That would mean true. If both are false, again, this is false. So again, disjunction looks at two claims that are together. So we can go through the same thing here. So if Abe is prime minister, everywhere it's A is true, 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 true. Hokkaido is great, so everywhere that's true is true, 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 true. So anywhere where anything is true, or will be true. So if then conditionals. So a conditional is something where there is a left side, which we call the antecedent, and a right side, which we call the consequent. So this one is a little bit strange. So let me explain. So as with many of the other ones, let's do this on the right-hand side. So Abe is prime minister, true. Hokkaido is great, true. So true, true. A true conditional. Okay, that makes sense. So this next thing might be a little weird to us. So Abe is prime minister, true. Rice tastes bad, false. This is false. So the same pattern happens for the next one. Abe is prime minister. You are a teacher. The conditional as a whole is false. So why? The answer is this type of argument is true if either the right side is true or the left side is false. Or we can say that another way. This type of argument is true in every case unless the left side is true and the right side is false. So why am I saying this is strange? The reason this is strange is this means the following conditional is true. If Dr. K is governor of Hokkaido, then everyone gets free ice cream. And this one is also true. If Abe were not the prime minister of Japan, then we would not need to pay taxes. So these claims are a little bit strange. So we'll talk about that more in class. But again, a conditional looks at two claims. So just to summarize what we've said. The word not is about one claim or one group of claims. The truth of not A is the opposite of A and is about two claims. So A and B is true if A is true and B is true, or is about two claims. A or B is true if A is true or B is true. If then is also about two claims. For A implies B, it is true if B is true or A is false. So last week we looked at 5 deductive argument forms. So I just want to show them to you again briefly. So this is modus ponens. The pattern is if P, then Q, P, therefore Q. This is modus tollens. If P, then Q, not Q, therefore not P. So if we look at this, this is following the same pattern that we talked about. Or to put it another way, for all of these, the only way that this claim ends up being false is if either this claim or this claim is false. So we'll look at this in more detail in class. So I will demonstrate with one that is 2 examples after this one. So a hypothetical syllogism. If P then Q, if Q then R, therefore if P then R. Again, what I want to tell you for right now is that using just the meanings we gave, the words if then, we can prove that if these 2 premises are true, then the conclusion must also be true. Or to put it another way, if the conclusion is false, then either this premise or this premise needs to be false. So let's demonstrate with this example. So this is a disjunctive syllogism. So we have a couple of operators. We have an or and a not. So let's work with our example. Either I am a bear or a duck. I am not a duck, therefore I am a bear. So to show an argument is valid, we are saying that if we have these 2 things true, the premises, then this also has to be true. So we're saying if it's true, then the conclusion has to be true. So let's look at it over here. To make not P true, we have to say that P is false. So let me repeat that. To make not P true, P has to be false, because not P is its opposite. To make P or Q true, if P is false, then Q has to be true. That means to make P or Q true and not P true, we have shown that Q is also true. So this is great. This is a wonderful feature. So let me just repeat part of the explanation. For P or Q to be true, at least one of the two has to be true. For not P to be true, P has to be false. So either I'm a bear or a duck. I am not a duck, therefore I am a bear. Now, you might be thinking, Dr. K, you're not a bear. And that is true. But what we have shown is that if the two premises were true, then it would follow that I am a bear, meaning no amount of evidence, no counterexample would work if the two premises are true. So to give maybe an example that might be easier, America either won or lost against Belgium in a friendly match or in the World Cup. America did not win, therefore America lost. So this one we could say this way, A or not A. Not A, ergo not A. So we just are selecting this, and then we are following that. If we wanted to reword it, we can reword it like this. So let me just redo this slide. So we could reword it like this. Won or lost. Not won, therefore lost. So this is exactly the same thing. All right. So we also saw another pattern of argument. So we saw two different versions of dilemma, and we can also show that these are valid. So I or C, either you will eat Italian food or Chinese food. If you eat Italian food, you will go to Caesarea. If you eat Chinese food, you will go to Oshol. Therefore, you will go to Caesarea or Oshol. So we could also show this is valid. But we can also see another type of dilemma. Either you will marry Tetsuya or you will marry Shin. If you marry Shin, you will become a mother. If you marry Tetsuya, you will become a mother. Therefore, you will become a mother. So this is great. This is exactly the sort of pattern that we want to find. And when we find it, we know it's a very strong argument. So every claim is either true or false. So things like Abe is prime minister, you like beef, pizza is cheap in America. It's safe to fly on any airline. Or ice cream is delicious. These things are either true or they are false. At the same time, every formula is also true or false. And in both cases, this is because of the law of the excluded middle, that anything is either true or false. Now, formulas can be, we could say, good formulas or bad formulas. So a more complex way to say this is well-formulated formula. But what we mean by that is formulas that follow all of the rules. So we talked about only the following things, not, and, or, if, then. The only other thing you can do in this sort of logic is add parentheses. So we say a formula is good if it follows these sort of rules. So not P, B and A, L and R, or C, A and C, and so on. But you can also have formulas that don't make any sense. So for instance, B and then not. Don't know what that means. T and, don't know what that means. C, D, or A, what does that mean? One thing that's great about this sort of logic is the grammar is easy. So you never need to worry about making grammar mistakes if you can just keep track of the 5 rules that we've learned, the and, or, not, parentheses, if then. If you can do that, you can say all sorts of things in logic. So I want to tell you about validity. So this is the key concept for making deductive arguments and understanding them. So please memorize this definition. If the premises are true, then the conclusion must be true. So this means there's two ways to think about whether an argument is valid or not. And we care about validity because that's a really great feature to have. Because that means no one can prove our argument false if we can just prove these premises are true. So this is a really great way to structure your writing. So to test is a very easy test. Start by making all of your premises true. So if you're making an argument, so if you're saying something like A or P, I will either eat an apple or I will eat pizza. I will not eat pizza. Therefore, I will eat an apple. So I showed you this one a little bit earlier, but we want to make both of these things true. So the only way to make not P true is to make P false. So if we make P false. But if we make P false, in order to make this sentence true, the only way we can make A or P true is if we make A true. And if we make A true, we've made our conclusion true. So to give another example, let's say I said this. Start with the same A or P. I will either eat an apple or pizza. So I'll repeat that. I will either eat an apple or pizza. I will not eat pizza. Therefore, I will eat pizza. So let me repeat that. I will either eat an apple or I will eat pizza. I will not eat pizza. Therefore, I will eat pizza. So again, start by trying to make our premises true. So the only way to make not P true is to make P false. And the only way to make A or P true is to make A true, because P is false. But if we do this, now P is false. So an argument where you can have all true premises and a false conclusion is an argument we call invalid. So I hope that this was useful and interesting to you. That's about all I want to cover today. And the idea that I wanted to do is to bring up these very simple operators. So just the words and, or, not, if, then. And if you can grasp that and you can remember what validity means and keep in mind the 3 laws of logic, it should be really easy for you to understand this way of thinking. Now, you may have a lot of practice in it, you may not. I want to give you more chances in class to work on these sort of exercises. Thank you for watching this flip. So again, please remember the operators and, or, if, then, and not, and the definition of validity. And if you remember that, you'll do great on the next quiz.